Hello, I'm Dr. Zia Tahir. This video tutorial is solution to problem 4 by 33 of Engineering Mechanics Statics 9th edition by J.L. Meriam. The statement of the problem is determine the force in the member DE and DL. So that is the member DE and the other one is DL. So as member forces in two members are required, so the best option to analyze this truss is using method of section. So I'm going to use method of section to find DE and DL. Steps to find member forces using method of section. The first one is plan a section cut. So need to choose an imaginary cut that passes through the target member and less than 3 unknown member forces. The cut must separate the truss into two stable parts. So one side can be treated as free body diagram. So for this one, so need to put a cut. So that is the member DE and that is DL. So if there are several options available and if I want to determine DE and DL in one go, so the one option available is this one. So I can put a cut here. But the problem with this cut section is that it is going to pass through 4 unknown. So then we have only 3 equation to solve it. So this cut is not possible. The other I can go for here. So that is a cut. So if I'm going to cut it from here, so I can only find DE. So once I'll find DE, then I can pass another cut there to find DL, or otherwise the other option is that I apply method of joints, add joint D after finding DE, so then I can find DL. So for this case, let's say if I'm going to put cut here, so and then I'll get two section, one on right and one on left section. So then I have to choose a simpler side of the cut with fewer loads, reactions, and fewer joints. So, and draw its free body diagram. So what I'm going to do, if I'm going to select that right end, so there is one given load there. But on left side, so there are two sports. I need to find sports reaction. So then it is finding sport reaction. So that will uh, that is not recommended here. So then I'm going to use that right end by putting a section there. And then for right, I need to draw its free body diagram. So the free body diagram is drawn, and on that free body diagram, I have shown external load 8 kilonewton at I, and then unknown cut member forces assuming tension. So DE is the one cut member force, then EL is the other one cut member force, and then KL is another cut member force. So the next one is I need to apply conditions of equilibrium to find unknowns. So use sigma m equal to 0, choose a moment point that has most unknown. Okay. So in this problem, DE is only required. So as DE is only required, so then I need to choose a moment point that has most unknowns. So it looks like that E that has most unknowns, E that has most unknown, but that EL and KL, they also pass through point L. So then is a possibility that I'm going to extend them like this way. So to get joint L there, and then I can take moment about joint L, because when I'm going to take moment about joint L, EL and KL, they are being eliminated because they are not required. So then I can find moment about point joint L. So sigma m about L is equal to 0, and for that EL and KL are passing through L, and DE. So DE and the distance is 2L. So that distance is here is 2L. So DE is going to produce moment in EL. So that is the direction of moment. So that is anti-clockwise. Now the line of action of 8 kilonewton is here, and the distance from the line of action of 8 kilonewton to L is a straight distance which is equal to 6. So now 8 kilonewton is going to produce moment in clockwise direction. So that is going to produce moment in clockwise direction. So then assuming that counterclockwise moment as positive, so DE times by 2, which is positive, then 8 times 6 is minus 8 times 6 is equal to 0. So then 2DE is equal to 48, and from here DE is 24 kilonewton, and DE is positive. DE is positive. So then interpretation of the sign, a positive value indicate tension and a negative value indicate compression. So then D is known, and DE is equal to 24 kilonewton in tension. So the next one is need to find DL, and for that purpose I can select joint D, and then for that joint D I can draw its free body diagram, and then just for joint D I can use method of joints to find DL. So that's free body diagram of joint D. At joint D, DE is in tension, so that is known, and then DL and DC are unknown both, but I need that DL. And now in the triangle DLC, so both sides are same, so the angle of DL with horizontal is 45 degrees. So I'm going to analyze that joint D now. Analyzing joint ED using method of joints is very much similar to passing another section there, section 2, and then at D, because D is known, so it is possible to analyze this part. So now at joint D, I am going to resolve DL into its components. So DL, it has one component DLX towards right, and then one component DLY towards negative y-axis. So now I can either go for sigma fx equal to 0 or sigma fy equal to 0, but in while finding sigma sigma x fx equal to 0 or along x-axis, I have only one unknown. So then at joint D, I can go for sigma fx equal to 0. Actually, so sigma fx is equal to 0. So dlx is towards right. So that is positive dlx plus 24 is equal to 0. So angle is 25. So dlx will be dl cos 45 is equal to minus 24, and dl is minus 24 over divided by cos 45. So that is 24 root 2 with minus, and that 24 root 2 is equal to 33.94 minus 33.94 kilonewton. So now the interpretation of sign is that a negative value indicates compression. So then DL is 33.94 kilonewton in compression. So now that is, this one is now DL is 33.94 kilonewton compression and DE is 24 kilonewton tension. And these are the answer. DE is 24 kilonewton tension and DL 33.94 9 kilonewton compression. And that is the solution to problem 4.33. And thank you very much for watching.